Hi and welcome to another lecture on precalculus, graphing an exponential function and its asymptote. You might be wondering, how is this any different from the previous two lectures with a similar title? The issue is the presence of, we are talking about the presence of a negative sign here in the function b to power of minus x versus having minus in front, minus b to power of x, or having in both spots minus b to power of minus x. Perhaps the reason the problem is stated in this way is that the students get confused what to do with that negative sign, and sometimes they eliminate it for the wrong reason, and we are going to take a look at that. So we are going to look at several cases. We are going to make our b to be some friendly number, no more fractions here for a while, so let's just 3 2 or something like that. It's just as good. Now so let me go ahead, pick an example here. Let me start with something like 2 to the power of minus x, and then you do the case for 3. So negative in the exponent as opposed to negative near the base. What's the difference? 2 to the power of minus x is a shorthand for 1 over 2 to the power of x. So if you want to make a table for this function, y, this is my function 2 to the power of minus x. Again, let's go ahead after some friendly numbers here. 0, 2 to the power of 0 or negative 0, it's the same thing, just 1. 2 to the power of minus 1, 2 to the power of minus 1, so we have to be careful. 2 to the power of minus 2, that's 1/4. 2 to the power of x is minus 1 now, and then there is another, so minus 1, that's just 2 to the power of 1, which is just 2. 2 to the power of negative 2, so that's 2 squared, which is of course 4. So what does the graph of this function look like? Here's my x, y, 0, 1, 2, minus 1, minus 2. So 2 to the power of 0, 2 to the power of 1 is 1/2. 2 to the power of 2 is 1/4. 2 to the power of minus 1, that's going to be 1/2. 2 to the power of minus 2, that's going to be 4. So the graph looks like this. And if we continue this, it's going to come closer and closer to x-axis. So the asymptote of this, the asymptote is, again, for all of the problems we have had so far, the asymptote for all these exponential functions we had so far is the line y equal to x, which is just our famous x-axis. This has to be compared against 2 to the power of x. 2 to the power of x, we had done this before. 2 to the power of x is like a reflection of the red one. If there was a mirror right on top of the y-axis, reflection of the red in that mirror would have been the green one. So y equal to 2 to the power of x is just that. Changing x to minus x flips the picture across the y-axis. Okay, perhaps this is not all that confusing. Next up is, what if I had y minus 2 to the power of x? What is confusing about this thing? Why is this issue brought up? Well, we're just looking at 3 times some fraction to the power of x, or minus 3 times some fraction to the power of x in the previous lecture. Why should this stand out? Because many students think, okay, this means, okay, the issue is, how do you read this thing? Is it you take 2 and raise it to the power of x, and then you kick it with a negative, or you take your 2, kick it with a negative, and then raise the power of x. Okay, so just like Shakespeare's question of to be or not to be, here the question is who goes first, and it is just a matter of convention. So you remember uh, the convention in mathematics from many years ago, perhaps uh, you have parentheses, then you have the exponentials, then you have multiplication and divisions, and you have the addition and subtraction, and then you have subcases. The issue really is that. So this is really excuse me, I don't know why does this happen. Okay, the issue is here is somebody's interested in, sorry for that. I guess YouTube wants me to repair my roof. So we have a minus, really is a minus 1 multiplied by expression, and the question is, do I calculate my expression first and then multiply by minus, or do I take that minus, let it do its thing, and then calculate? Well, exponentiation comes before multiplication. Okay, exponentiation, so we have an order of our agenda is exponentiation, then we have multiplication, and division, and then we have addition and subtraction, and above all of these things we have parentheses actually. And there are other finer detail here. If you have multiple exponentiation, it goes from top to bottom. Multiplication, division, if you have ambiguity, you go from left to right, and so on. So in this case, exponentiation comes first, and multiplication happens later. So when I want to make a table, I am clear as to what's happening here. X minus 2 to the power of x. Let's put 0, 1, 2, minus 1, minus 2. 2 to the power of 0, so I have minus 2 to the power of 0. This is minus times 1. So I get minus 1. Okay? Minus 2 to the power of 1. Well, that is minus times 2 is minus 2. Minus 2 to the power of 2. Again, not to be confused with the following. What's minus 2 squared? Well, minus 2 squared is 4. But minus then 2 squared, that's going to be minus 4. And so on. So minus 2 to the power of minus 1. These two negatives don't talk to each other. 2 to the power of negative 1 goes first. That's a half. And now this is minus a half. Minus 2 to the power of minus 2. This happens first. That's a quarter times a minus becomes minus a quarter. So what do I get after all of this? When I draw this picture, a minus came in front of my values. So at 0 I get minus 1, at the 1 I get minus 2, at 2 I get minus 4, minus 1 is a half, minus 2 I get a quarter. Let me draw it in some other color that stands out. So this is minus 2 to the power of x, as opposed to what? As opposed to 2 to the power of x. 2 to the power of x, to draw it quickly, putting this minus, flip the picture upside down. You notice? When you multiply a function by minus, it flips upside down. Okay, so what is the third variety here? We have uh, both minuses here. So now I have y is equal to minus, say, 2 to power of minus x. The two minuses, each of them do their own thing. They don't cancel or they don't do anything else. So let's just draw this thing again. So if you want to write it, it's minus 1 over 2 to the power of x if you wish to. So this minus is minus in front of a fraction. This minus x simply means take your 2 to the x and flip it upside down. So if I have my x and y now, again, let's 0, 1, 2, minus 1, minus 2. At 0, 2 to the power of 0 is 1, and here I get minus 1. This is minus 2 to power of minus 1. It's going to be minus a half. Minus 2 to power of minus 2. That's going to be minus 2, excuse me, minus a quarter. Let me correct this. And here minus 2 to power of minus 1. If I didn't have enough minuses, now we have 3 of them. X is negative. There's a negative in front of it, and there's a negative in front of the expression. These two cancel each other out. That one just stays put. So I have minus 2, and this is gonna give minus 2 power of negative 2. It's going to give negative 2 squared, and that is negative 4. Again, 2 squared goes first because exponentiation has priority over multiplication by minus. Well, what does that picture look like? Well, I leave the detail to you, and in this case we have, as we go toward the positive, you notice these things are negative and getting smaller. So I'm coming close to, so this is a graph of minus 2 to the power of minus x. Now when you're doing this graphing, of course you have to draw it on Alex's screen and pick your numbers carefully. But other than that, the idea we expressed is the main one. So the question is, this minus here, or the minus is here, or the minus is in both places. We have to be careful with how we are reading or interpreting the function. Okay, that's it for this mini lecture. Until next time, good luck and God bless.